Hello there, and welcome to our first of two lectures on intelligence. In today's lecture, I'm going to focus pretty specifically on one key idea about intelligence. I'm going to be contrarian. I'm going to argue against something that practically all introductory psychology textbooks teach, although my book certainly calls this assumption into question. I'm going to talk about the idea that IQ, at least I'm going to try to, I'm going to talk about an idea that I think most textbooks get wrong. I'm going to talk about the idea that IQ is just one thing. You get one IQ score, not 11 or 8 IQ scores. I'm going to talk about what I call the myth that IQ is just one thing. And going along with that myth, another part of it is the idea that people vary greatly in how much they have of that one thing. So let's look at a metaphor or two. Money is just one thing. You can convert, euros to dollars to pesos to some other currency, but money is money. And if you have $1 million in American dollars, that's a lot of money any place on earth. Now it buys you more in Ecuador than it does in Canada, but money is money. And so there are things that are one thing. Kindness might be kindness. That's actually a great thing. Personality researchers would probably debate whether kindness is just one thing, but I think it's not too controversial to say that if kindness is one thing, one personality trait, that people differ on that trait. So I'm not going to push back against kindness. I have a vague sense that kindness is a personality trait. I suspect that people have documented that it is. I certainly know that there are individual differences in things like empathy that contribute to kindness, but I'm going to push back hard against the idea that IQ is just one thing and that people vary greatly in how much of it that they have. So that's the idea here, to look at assumptions about IQ. These assumptions have been around for going on about 100 years now. IQ tests have existed for 115 or so years now. So to begin this critique of what I call the myth of IQ, I'm going to emphasize the fact that forms of intelligence, highly sophisticated reasoning, skillful planning, memory, all the things that we tend to think of as a part of IQ, they show up in lots and lots of places where you might not expect to see them. And it's very easy to find people or animals even who are extremely intelligent in one particular way, but not in other particular ways. So let's look at that. IQ does stand for the intelligence quotient. I guess I better tell you that first. Back in 1905, I think it was 1904, 1905 in France, the church and state separation began. So it used to be the case in France 150 years ago that everybody got educated by the church. In about 1904, 1905, that changed, and now it became the job of the French government to educate people. And at about that time in 1905, Alfred Binet said, okay, now that we radically reinvented our educational system, I think we should check people out. We should give people tests to see who's really good at reasoning, thinking, remembering, and who's not, so that we can match people to the right kind of educational program. So in principle, I guess that sounded okay. And that idea was really welcomed in the United States in 1904, at the very beginning of when folks were doing this work in France. Charles Spearman proposed that G, or general intelligence, is something that people either have or don't have to varying degrees. So just like some people are 6'5" and some people are 5'8" and some people are 5'7", Spearman said there's this thing called G, general intelligence. It contributes to everything you do, whether it's memory, problem solving, creativity, mental rotation. G is ultimately behind that. Now that's a theory, but as it turns out, even Spearman, who was a rabid, well, let me say avid, I would say rabid, many would say avid fan of that theory, had difficulty supporting it as he actually delved into his data. But let's keep going a bit here. He did believe, and some people still believe to this day, that if you're very good at math, that means there's a part of you that makes you that way, that generalizes to memory, generalizes to verbal ability, mental rotation, generalizes to processing speed, any mental skill a person would want to have. The idea of G for general, is that you have it or you don't. If you got a lot of it, good for you. You're smart across the board. If you don't have a lot of it, too bad for you. You're not going to be so smart across the board. So that's the idea that I'm critiquing. And Spearman popularized the idea well over 100 years ago of giving people a single IQ score. If you take an IQ score to this day, let's say you take an IQ score, something like it, to see if you qualify for a talented and gifted program, you'll probably get one score. If you take the SAT, you'll get one score that's broken down into 2 or 3 scores like verbal and math, but people still tend to think of IQ as just one thing. My question for this lecture is that really true? And again, I'm going to push back against that idea at least a bit, maybe a lot. Okay, now this is time for a sort of weird detour, and the detour I'm going to present here really has to do with a sort of an approach to thinking about the mind and mental or intellectual abilities that is pretty heavily influenced by my interest in evolutionary psychology, my interest in things like animal cognition. So before we jump into people at all and ask if Spearman was correct that IQ is just one thing, I'm going to talk about the fact that every year in psychology for the past 2 decades, there's been a landslide of information and research that suggests very clearly that animals have much, much greater mental abilities than we ever thought they did 20, 30, 40, 50 years ago. So 100 years ago, we thought that there were all kinds of things that only we can do. And every decade, every year, we uncover new things that animals can do that we once thought they could never do. Let's begin with Chaser. Speaking of Chaser, my dog Bella must have heard me speaking of another dog. Let's look at Chaser, the dog with a 1,000 word vocabulary. And of course, I'm going to pause here because it takes a long time to get this video up. All right, here we go. Whoops, I hope.
It's part of our pop culture to give animals human personalities and talents. Good boy, good boy. Movies and cartoons are filled with talking creatures who basically act like people, but they've got feathers or fur, from Donald Duck to Alvin and the Chipmunks.
I paused it to see if I can pull up some subtitles. Hold on just a second. I think I can. Oops, sorry, I didn't notice I was still running. All right, now we're going to get subtitles.
And when it comes to our own pets, it's awfully tempting to imagine that they have human thoughts and feelings. But researchers have always been skeptical about animal intelligence. After all, we humans speak and write and build spaceships and solve puzzles. Yet animals, well, they're just not that accomplished. Yet recently, as we test more animals and try to reveal the way they think, we've come up with some surprising results. And these days, one of our star pupils is the one animal who may know us the best.
She's a wonderful little dog. She is something special. She's really smart, and we have this connection.
She is extremely intelligent.
I think that she is very much like a person.
I think Tucker understands me more than anyone else.
Plenty of dog owners have always said their dogs were smart. But animal researchers are just starting to catch on.
1, 2, 3.
New discoveries are showing that our best friend is smarter than they ever thought.
Good job.
And behind those big brown eyes lies a brain that resembles ours in ways we never imagined.
Here.
John Pilley, a chipper 82-year-old.
Come back.
All right, I'm sorry for all the skipping around, but I realize I'm going to stop this clip before it finishes, and I want to say a little bit about what you're seeing right here. What you're seeing right here is a very clever study done on dogs with their owners, and the basic idea of this simple study is to put a treat under a cup, and every time they do the activity, one cup has a treat, the other cup does not have a treat. The dog has no way of knowing what it's there, and they even control for smell, by the way, because dogs could smell which cup has and which cup doesn't. So they have the owners of the dog simply point to one cup or the other, and dogs very quickly cue into the fact that my owner is telling me, flip over that cup. That's where the treat is. So you do it trial after trial after trial, and dogs very quickly pick up on this. Chimpanzees, which we stereotype at least as being much, much smarter than dogs and not that different than people in certain areas, never get this. So This is an example of a particular area, and it's certainly not every area, in which dogs are meaningfully smarter than chimpanzees. And we're going to see later, there are plenty of areas where chimpanzees are smarter than dogs, but this is one example of what I call the insularity or the modularity of genius, that an organism, that includes a person, can be really, really smart at one kind of activity and not so smart at all at another. All right, let's get to Chaser next, who's very smart at a couple of things that we once thought dogs could not do.
Good job.
And behind those big brown eyes lies a brain that resembles ours in ways we never imagined.
There.
John Pilley, a chipper 82-year-old,
Come back, hurry.
started working with dogs as a psychology professor.
Walk up.
Now, he's got one of the smartest dogs around.
Come on, girl.
And I've come to check out what she can do.
Good girl.
Chaser is a 6-year-old female border collie, a breed famously skilled at herding sheep.
She was born to live in the Scottish mountains. Chase, toe, and herd sheep. Go. There, be a shepherd.
John has taught Chaser to tend an extremely large herd.
That was a sheep.
But there are no real sheep in it.
I can't believe
Chaser's herd is made up of toys. About 1,000 of them.
And she knows the name of every single one of these?
I hope.
Sailor. John has assigned a name to each one.
Never forget. Oh, because it's
And taught those names to Chaser.
It's an elephant, okay?
She has about 12 elephants.
Apparently, sometimes John ran out of stuffed animals.
Uh-oh, these are a pair of my shorts.
Oh, my God.
No, because that's one of her toys.
John claims that Chaser remembers the name of every single object in the pile. Personally, I find that hard to believe. I don't have time to test Chaser's memory on 1,000 names, but I will test her on a random sample. John and Chaser go into the house so they can't see.
So I'm going to get a handful of toys out of this pile and see if Chaser can identify them indoors.
With John and Chaser out of the room,
All right.
I lay some of the toys out behind the couch.
Inky. There's Lover.
Now it's time to see if Chaser really remembers their names.
All ready for Chaser. Come on, Chaser. Come to Neil. Okay, come on down. Quick. Chaser, find Inky.
Well, she got one right.
Find Seal. Whoa!
And that one too.
Okay, ready, Chaser?
Now, you might be wondering what's going on behind the couch. Like, is John handing her the toys?
Find Crawdad.
Let's check our hidden camera.
Find Sugar. I asked Chaser to find 9 toys, and she got every single one right.
And remember,
I picked the toys randomly from this huge pile. Neither John nor Chaser saw which ones I picked. On multiple trials with John and others, Chaser consistently aces her test. There's 1,000 toys here. That doesn't, like, spook you? Makes me happy. These dogs have super memories. On your mark, get set, go! Over. Chaser and other border collies like her have shown they can remember hundreds of words and what they represent. Cable. Reverse. In, out, in. What's more, they can learn these new words very quickly. Over. Cable, Chase, cable. Good girl. So, how does this ability compare with other species? Well, besides us, chimps and bonobos are the animal kingdom's top linguists, capable of learning sign language, but very slowly. There are tests where dogs perform much better than apes. Consider this simple task. By the age of 12 to 18 months, a human baby knows to look or go where a grown-up points.
What do you think?
Oh, I forgot, we are going to watch this, so.
This is something that little children do right when they start to borrow language.
Brian Hare is a primate researcher who tried this experiment with some of our closest relatives, chimps and bonobos, with surprisingly bad results.
Primates really struggle if you try to help them and you try to cooperatively communicate to them about the location.
I did pause this here because there's an extensive section on dogs and wolves and comparing dogs and chimps and wolves. I'll give you that in a nutshell. Dogs can do the activity you see right here really well, learn it very quickly, just like human toddlers or human preschoolers can. Chimps practically never learn it, and wolves don't learn it. And my theory of the reason why is that we bred dogs over 5,000 to 8,000 years by having them live with us and loving them and getting rid of the ones that try to eat our toddlers. We basically selectively bred dogs which are genetically almost identical to wolves, but not quite identical. We bred them to love us. Wolves do not love us because they love us and care about us, and because they're social creatures. They're very, very good at picking up on the cues that we give them for what we want them to do. Now we're going to get back to Chaser in just a second here and see another amazing thing that Chaser can do that shows sophisticated reasoning abilities. All right.
Them to pay closer attention to humans, and as a result, makes them more flexible students.
Fine meal.
Take Chaser, John Pilley's brainy border collie. Let's see what she does when we challenge her with a new toy she's never seen or heard the name of.
I smuggled this into your house. It's a Charles Darwin doll. Okay, so I put 7 toys behind the couch, plus Darwin. Chaser's never seen Darwin, hasn't even ever heard the name Darwin. So let's see if she picks out Darwin by inference. That's what we're going to check. Go to the corner now. Chaser, come on back. Let's have some more fun. First, I'm going to ask Chaser to find a couple of toys she already knows. Find sugar.
Excellent, Chaser. Chaser, good.
Okay, put it in bed. Find Quadad.
Excellent. Excellent. Good job.
Okay, put it in the tub. Put it in the tub. Okay, here it comes. A name she's never heard before. Find Darwin. So while searching for the other toys, Chaser knew exactly which one to pick up right away. But now, she seems to have to think about which one might be Darwin. It's taking her longer. She takes so long. I called her back. Chaser? Find Darwin. Find Darwin. Finally, she makes a choice.
Darwin! It got Darwin!
I can't believe it. Chaser's never seen that doll before.
Darwin! That's Darwin! You're a good girl!
Yet somehow, she made the connection that the name she'd never heard before
You found Darwin!
went with the one toy she didn't recognize.
Good girl!
Chaser's not the only dog to do this.
That's Darwin!
And what's more, dogs like Chaser have shown that they will remember the connection they made between new name and new toy.
It's a great place to stop. So, a couple of quick points about Chaser. The most important point right here is that Chaser engaged in a very thoughtful, you could say, a very thoughtful form of if-then reasoning. She knows this is Sugar, this is Prodhead, this is Inky, this is Blinky, this is Sneezy, whatever the other toys are, and she was able to draw the inference that if that's the only one I've never seen before, and that's the only term I've never seen before, they must go together. So that's pretty impressive, and Chaser's not the only dog to do that. All right, I hope you noticed 2 or 3 things that are very impressive about Chaser's reasoning abilities. Okay, so there are 3 things I'd like to draw your attention to. There we go. First of all, Chaser can do something called fast mapping. That's a term that originated with people who study language and language learning, and it's typically been applied to human toddlers and not even older human kids or human adults. So at a pretty young age, human toddlers and preschoolers very quickly learn the meaning of new words they've been exposed to once, maybe twice, and we were once pretty convinced that only people can do that. Chaser is another organism, another species, a non-human animal that can also do fast mapping. Use a word once, maybe twice around her, and she's got it. Even human adults can't easily do that. Only human toddlers and preschoolers can do that. All right. Chaser, as I'm sure you recall, has a vocabulary of more than 1,000 words. That's way more than in any other non-human animal. And as you saw in the end of the clip there, Chaser can engage in relatively straightforward, pretty simple forms of if-then reasoning, which is not unheard of in the animal kingdom, but it's relatively rare, right? It's not rare in parrots, and this famous parrot, Alex, is really good at if-then reasoning and a lot of other kinds of logical reasoning, and I'll share that with you next. All right, here's Alex, the gray parrot.
Alex, what matter? That's right.
Wool. It's made of
How
wool.
many? That's right. You're a good boy. No, sweetie. No, you can't go back yet. You gotta.
You want some water?
All right. Do you want some water, or are you just asking to interrupt? You're just asking to interrupt. I know. I know. Okay. What color bigger? What color bigger? Green. Oh, you're a good boy. Okay, Alex, look what I got for you. Hey, look. Look at all these neat toys. Look. Hey, look, can you tell me? On the tray, how many green block? Green block. Good parrot. 2 green block. 2. Good parrot. One of the things Alex doesn't have is a knee-jerk response to the types of objects that you present him. He can look at 2 objects and answer several different types of questions about those objects, or he can look at a novel collection of items and answer questions about that collection. What this shows us is that he really understands what those questions mean.
The whole thing.
Yes, Alex.
You're right, good boy.
Alex describing objects. Alex saying, Polly want more than a cracker.
Is what you want? I want banana. Carrot.
Good birdie.
I want corn. Soft corn.
Soft corn. Good parrot. We've got rock corn, that's dried corn, and we've got soft corn, too.
Cold.
It's cold. Yes, it's cold. It's from the refrigerator.
Go pick up corn.
Well, no, I'm not going to pick up the corn you threw down.
Using his beak, he could tell you what matter objects were made of.
Rock? Good boy. What matter?
What matter, Alex?
What? Good boy.
Whoa. That's right. Whoa.
And amazingly, on a tray, he could tell you the number of squares from the number of balls, the number of each color.
How many blue balls?
Four.
Four is right. Good parrot.
He's choosing from among all the possible answers. Remember, he sees this object. If he was giving a knee-jerk response, he would say paper every time he saw this thing.
He tried to restrain himself when student parrots like this one got it wrong.
What matter?
Then Alex would interject with his equivalent of duh.
What matter?
What?
As parrots go, he was simply Einstein. When we were there, even Einstein got hungry.
Well, you're the boy.
Want to go eat dinner?
I know. It's time to eat dinner, sweetie. I know it's time, but we have to do one more chore, okay?
And then Alex declared it was over.
You want to go back? You want to go back?
And now, somewhere in parrot heaven, the angels are marveling at what God wrought. Alex the parrot has died at the age of 31.
All right, so sadly, Alex passed away about 13 years ago at the time of this lecture, at least. So I don't think 31 is even that old for a gray parrot. I think they can make it to like 50. But he in his life in the laboratory learned some amazing things that people simply did not think animals could do. In fact, when I worked at the National Science Foundation, one of the legends or one of the stories about grant proposals and being thoughtful and not being narrow-minded was the first few times that the woman who worked with Alex, Irene Pepperberg, I think is her name, the first time she proposed her grant proposal, she was practically laughed at, but she just kept collecting pilot data and kept showing what Alex could do, and eventually got funded, eventually published papers that really dramatically changed the way people thought about animal cognition. All right, let's pause it and we'll get back to the lecture. Okay, so what could what could Chaser do? Chaser could do a couple of things. What could Alex do? I skipped backwards here, didn't mean to. Let me see if I can back this up or go ahead where I want to be. I'm going to see if you'll live with that little mistake and keep moving. I have difficulty getting the screen to advance on it. All right, here we go. Alex could do 2 or 3 things that Chaser could not do. First of all, Alex could make logical judgments about objects that he had never seen before. So if you showed Alex, triangles that he had never seen before, and one was green and one was blue, he could tell you which one was bigger, for example. So he could make logical judgments about things that he'd never seen before. He could count things. He could categorize things by color, shape, and physical makeup, for example. And of course, luckily, and I think this is what impresses people most about observing Alex, the fact that he could speak, at least mimic human speech, made it easy to study him because he could give you verbal answers instead of pecking or pointing or doing things like other animals have to do. So it's lucky for those who study parrots, for example, that parrots can have at least some limited ability to mimic human speech. Now, having said that, other parrots that can also imitate human speech have not been able to do some of the things that Alex could do. So until we see lots of parrots do this, we'll be having debates about exactly how common that is. The next thing I'm going to share with you is something that multiple chimpanzees can definitely do, and that's something that Alex or Chaser could certainly not do. We're going to talk a bit here about the work of primatologist Tetsuro Matsuzawa, who studies place and number memory in chimpanzees. And you're going to see a video here in just a minute of a Yumu, who is the best of many chimps who've been tested on this activity. So Yumu will see a series of numbered squares appear in random spots on a computer screen. Okay, so bunch of squares on a computer screen. I think you're going to see 9 or 10 of them. I believe a Yumu can do this with as many as 19, but we'll see 9 or 10 squares. The squares will be numbered 1, 2, 3, 4, 5, 6, 7, 8, 9 all over the screen. And a Yumu's task, not Alex's, is a memory activity. You can try to do it with them once you watch. The numbers on the squares will disappear the moment a Yuma touches the very first square. Now, there are more difficult versions of this activity that a Yuma can also do. I'm going to show you the basic version. Once he touches that first square, all the other numbers will disappear, and you will see that a Yuma will touch all the remaining squares in numerical order. All right, we're back, and I'll just give you a quick summary of what we just saw with the Yumu. At least I'll try to. Notice, by the way, that human beings would crush chimps when it comes to language and math. Obviously, where you're listening to me lecture, a Yumu doesn't lecture. Dogs crush chimps when it comes to something called theory of mind, understanding the intentions of other people, for example. So I'm making the point here that animal IQ or animal intelligence is almost certainly survival skill specific, and I'll give you one more quick example of that without needing a video. If you look at chickadees, and there are many, many different species of chickadees, we're going to look at chickadees here. These are little birds that live often where it's very cold. They weigh, their entire body weight is about half an ounce. They're very, very teeny, slightly smaller, I think, even than a sparrow. They're tiny little birds, and despite the fact that their entire bodies weigh less than half an ounce, so obviously their brains are much smaller than half an ounce, they can remember every year where they've hidden 50, 60, 70, 80,000 individual seeds over the course of the winter. So they spend the summer and fall gorging and hiding seeds. And when the fall comes and the first snow comes, and then the ground is covered for snow for several months in places where they live, they remember the location of virtually all of those seeds and retrieve them one by one, day by day in the middle of winter when they otherwise would starve to death. So that's an example of a super tiny brain, literally a bird brain. It's the brain of a bird that allows that bird to have an amazing memory that I can't think of any people who could do that. So we have another example here. These birds can't do what Chaser can do. They don't have fast mapping. It's not clear if they can do if-then reasoning, but they have amazing memories because they have to survive the harsh winters where their species has existed for many, many thousands, if not millions of years. So chickadees crush chimps when it comes to long-term place memory. Chimps might or might not crush chickadees when it comes to the kind of short-term memory that we just saw with chimpanzees. Okay, so those are 4 animals that excel in particular activities or skills, but would not excel in other activities or other skills. I think I'll summarize this for you and then take a break in this lecture. So I think I might chop up intelligence into 3 lectures, not 2. But before I pause, before I break, let me make the point here. There are 3 I'm making so far. First of all, animals have much greater thinking and problem-solving skills than we thought for decades in psychology. Decade after decade, we believe that only human beings could do lots of things. There are things that only we can do. Only we invented smartphones, although that was only a couple of us who did that, by the way. Only we produce, music and art, for example, at least at the level at which we do it. So I'm not saying animals are just like us, obviously, but I'm saying they have much greater, much more sophisticated skills than we once believed. So that's point number 1. Point number 2, which is closer to the core theme of this lecture, animals that have amazing intelligence in 1 or 2 particular areas might possess very limited intelligence in other areas. So the particular skills or thinking abilities that animals have are unique to what helps them survive in their particular environment. And that suggests, those 2 things suggest, and I'm going to suggest this again by looking at people, that intelligence is not just one thing. It's not that some birds are smart and other birds are dumb. Intelligence is modular. And by modular, I mean it's highly insulated, highly isolated to a particular skill or ability. So a person or an animal that happens to be brilliant in one particular way, great long-term memory for location, might have little or no intelligence in other ways. So for example, to compare people and dolphins, dolphins are amazing at echolocation. We can't do echolocation, not just because we don't send out the sound waves that bounce back, but also because our brains aren't wired to be great at echolocation, with an exception that I'll get to later in the second lecture. So for now, I think I'll stop here and take a break, stopping with what we know about animal intelligence. And after this lecture, I'll move on to some examples of human geniuses. And in the case of people, as well as in the case of animals, we're going to see examples of genius where you might not expect to see it. Thank you. See you later.